Hi, I'm Bradshaw from Hexagon. During this video we will use PV Elite to start creating a basic pressure vessel model. We'll see how to set up the load cases, set the wind and seismic loadings, and we'll also see how to check the wall thicknesses against the code requirements at all times during the input. Alright, so as we saw before, when we first start PV Elite we see the nozzle database dialog box, but what we also know is that everything will be in US units. So first of all, let's change our default units file. So first of all, click OK on this dialog box. Doesn't matter which option you've chosen, we're not going to use that here anyway. And then in PV Elite, go to this button here, the configuration parameters. Now within the configuration window, we can go to the default value settings page, and in here we can change various things, including the units file, which is here on the right hand side of the screen. So the default is the english.fil units file. I'm going to change this to one of the metric ones, such as newtons.fil. You can also create your own units file, but for this example I'm just going to stick with one of the out of the box units files. As soon as you change that, you then see a message, these will be the default units next time you start PV Elite. So that's OK, and now we need to restart PV Elite. So I'm going to close and reopen the software. Alright, now I've restarted the software. As we can see in the background, the units is now the newtons metric units file which I've chosen. So let's start and build a vessel. I'm going to use the ANSI metric nominal pipe size for the nozzle database here. So the units for nozzles will be millimeters. So we have 100, 150 nominal size nozzles rather than 4 or 6 inch. So OK. And let's start creating the model. Now, most of the data input is done in the general input panel, which is here, currently disabled because the model is currently empty. But there are a few other panels as well available here. So we have design constraints. This is where we can set global information such as a global temperature, pressure, etc. Change the hydrotest type, set the MDMT, MAWP, etc. Can all be set from within this panel here. For this example, I'm going to leave everything as the default. And then on the next page, we can set up the load cases. These are the default load cases for the ASME Division 1 standard. If you choose EN13445, you'll get a different set of load cases, but these are the default load cases which satisfy the requirements of the standard, and these are combinations of the various different loadings. Of course, you can change these load cases and you can adjust the default load cases, and if you want to do that and you want to know what the loadings are, you can always hit F1 on your keyboard to open up the help, which is context sensitive, and this will load up the help as appropriate. So here we can see the various different types of loadings that are available. Again, I'm going to accept all of the defaults here for all of the load case options. Some of these loadings are for wind and seismic, which are available on the next two pages. Here you can choose the appropriate wind design code or seismic design code and enter in the appropriate information. Same for seismic. And the final page is the header page. This is just heading information which will appear on your reports when you generate the output. For example, I'll just type something in here and we'll see this in the output. So let's start building the vessel. This will be a vertical pressure vessel, and for a vertical pressure vessel we start at the bottom and build upwards. For horizontal, we start at the left and build towards the right. So I'm going to start with the first component, which will be the skirt. So I'm going to do this just by hitting the Insert a Skirt button up here on the ribbon to attach the skirt. Here is my skirt. If I move to orbit mode in the graphics, I can spin the model round, I can zoom in and out using my mouse wheel, as you would expect, similar to a CAD system. But this is not so interesting at the moment. So I'm going to change the length of the skirt first of all. So it's just over 3 meters. I'm going to make it a little bit shorter, 2.5. And then I'm going to add a base ring as well onto the skirt. This can be done by going to the Perform Base Ring Analysis field on the general input page and check the box to perform the base ring analysis, which allows me to add a base ring. First of all, choose the type of base ring, perhaps one with gussets, and then we can set the various parameters, material data, geometry for the base ring, for the bolts, and for the gusset plates as well over here on the right hand side of the dialog. For this example, I'm going to accept all of the default materials and all of the default geometry data as suggested to me by PV Elite. So I'm just going to click OK. And there's my skirt base ring. Okay, the next component will be the first Bradshaw part. This will be the bottom head. So I'm going to go and select to insert an elliptical head, which is inserted like so. It's obscured by the skirt, so if you wish to see that, you can hit this button here to make the shell semi-transparent, and we can actually see the head is placed and it looks okay. However, it's not okay because we see some red text down in the bottom right hand area of the screen. This is calculating that TR, thickness required due to internal, and TREXT, thickness required due to external pressure, is 9.26 and 9.509 millimeters respectively. The MAWP is also 0.4. These are shown in red because, well, my pressure is 0.689 and my thickness is only 6.35. So PV Elite is constantly doing the calculations for me, at least in terms of pressure containment, and I can see immediately this needs adjusting, and I'm going to change the thickness to 10 millimeters. As soon as I make that change, the calculations are rerun, and as we can see now that we are acceptable, all of these numbers have reverted back to the original color. I'm going to reset the view back to the default front view, and I'm also going to turn the transparency off. Now I can continue on and add my next component, safe in the knowledge that my head is acceptable, it's thick enough from the pressure containment standpoint. So I'll next add a cylindrical shell. I'm also going to adjust the length, just round it down to 3 meters. And once again, I see some red text down at the bottom of the screen. Again, I can adjust this to, let's say, 13 millimeters. Or alternatively, on the design constraints page, I can choose down here to say, select the wall thickness for me automatically for internal or external pressure, or even add stiffening rings or select on axial stress. As soon as I change any of these to yes, for example, external pressure was my issue, as soon as I change that to yes, you see the text is no longer red, and back on the general input page, the finished thickness has automatically been set to 13 millimeters. So again, everything is okay from a pressure standpoint. I'll go on and insert a conical section and adjust the length. Let's change this to, say, 1.5 meters. And let's add a cylindrical section and a second one for the top strake. And let's insert a top head as well. And there we have it. Very quickly, in just a few minutes, we've built the main body of the pressure vessel, and we also know that everything is thick enough from a pressure containment standpoint. So I hope you enjoyed that video and found it useful. But remember, if you do have any questions at all, please don't hesitate to reach out to us at Hexagon. Thanks for watching.